Question number 1. In outer space, a rock of mass 7 kg is attached to a long spring and swung at constant speed in a circle of radius 6 meter. The spring exerts a force of constant magnitude 780 Newton. What is the speed of the rock? F net in the y direction equals spring force minus weight, which is mg, and centripetal force equals mv square over r. Since the net force provides necessary centripetal force for rock to move in a circular motion, net force equals centripetal force, which is spring force minus weight equals mv square over r. And plugging the values of spring force 780 Newton and weight and equating it with mv square over r, we get the velocity, which equals 24.7 meter per second. What is the direction of the spring force? The direction of the spring force is toward the center of the circle, that is radially inward. See, the relaxed length of the spring is 5.7 meter. What is the stiffness of this spring? Spring force equals spring constant times change in length. Spring force, which is given 780 Newton, equals spring constant, and the change in the length 6 meter is the extended length and 5.7 meter is the original length, and we get K equals 2600 Newton meter, stiffness of the spring. Question number 2. A box of mass 50 kg hangs motionless from two ropes as shown in the diagram below. The angle alpha is 22 degrees. Find the forces as vectors for the tension in both of the rows. The figure is shown. The tension T1 acts toward the wall in negative x direction, and the T2 acts on the wall at 22 degree to the vertical. And this is rope 1 and this is rope 2. Since the system is in equilibrium, net force equals 0. Net force in the y direction equals 0. So in the y direction, it's T2 cos 22 degree minus the force on the negative y direction, that is weight. So F net y equals T2 cos 22 degree minus mg, and T2 cos 22 degree equals to mass times gravity, which gives T2 equals 528 Newton in magnitude. Similarly, net force in x direction equals 0. So T2 sin 22 degree minus T1 equals 0. T1 acts in the negative x direction, while the component of T2, that is T2 sin 22 degree, acts in the positive x-axis. So their net force equals 0. T1 equals 528 sin 22 degree, which is 198 Newton, and the T1 in the vector form is minus 198 Newton. Since the T1 acts in the negative x direction, T2 equals 198, that is the x component of the T2, and T2 cos 22 degree, its particle component is T2 cos 22 degree, and the J component is 0. So it's 198, 490, 0 Newton.